Welcome to a journey that will challenge the very core of what you think is real. In our everyday lives, we take reality for granted. The world feels solid, predictable, and normal. But what if I told you that the reality you experience might be just a thin layer, an illusion covering something far stranger, more intricate, and mind bending than we could ever imagine? Throughout history, the greatest breakthroughs in science have come from questioning the obvious. Newton gave us the laws of motion, laying the foundation for classical physics, and Einstein showed us that time and space aren't as fixed as they seem. But the past century has thrown us into entirely new territory where particles act like waves, black holes can store information, and the universe may be woven from vibrating strings. In this video, we're going to peel back the layers of reality and explore the physics theories that are redefining what it means to exist. From the puzzling world of quantum mechanics to the bizarre idea of extra dimensions and multiverses, we're diving deep into the science that could reboot how we see reality itself. So buckle up, because by the end of this video, you may never look at the universe the same way again. If there's one area of physics that truly turns reality upside down, it's quantum mechanics. At the subatomic level, the rules of the universe seem to change entirely. Objects don't behave as we expect, and the very nature of existence becomes uncertain. Take wave-particle duality, for example. Imagine something as simple as an electron. We think of it as a particle, right? But according to quantum mechanics, that same electron can also behave like a wave. It's as if the electron exists in multiple states at once, both a wave and a particle, until we observe it. This mind-bending idea is at the heart of quantum physics, challenging our basic understanding of how matter behaves. Then there's quantum entanglement, a phenomenon so strange that even Einstein called it spooky action at a distance. When two particles become entangled, their properties become linked no matter how far apart they are, whether they're on opposite sides of a room or the universe. A change in one instantaneously affects the other. This defies everything we know about space and time, raising deep questions about the fundamental nature of reality. At the quantum level, the universe seems uncertain, interconnected, and frankly, bizarre. And these strange behaviors aren't just theoretical. They've been observed and tested time and time again. It's almost as if reality as we know it is just an illusion, hiding the true complexity beneath the surface. So, what does this all mean for our understanding of reality? It means that the classical, predictable world we live in might just be a special case, a simplified version of a far more complex universe. And as we dive deeper into quantum mechanics, we're forced to ask, is reality something we can ever truly understand? Few things in the universe are as mysterious and awe-inspiring as black holes. These cosmic giants are so dense that not even light can escape their gravitational pull. But beyond their ability to trap light, black holes challenge some of the most fundamental laws of physics. At their core, black holes represent a breakdown in our understanding of space and time. Inside the event horizon, the point of no return, time itself seems to stop, and our traditional concepts of physics fall apart. But one of the biggest puzzles black holes pose is what happens to information when it falls into them. In classical physics, information about particles such as their position and state should never be lost. But according to Stephen Hawking's discovery, black holes slowly emit radiation, which means they eventually shrink and evaporate over time. This led to the famous information paradox. If the black hole evaporates completely, does the information inside it disappear forever? That would violate a core principle of quantum mechanics, that information must be preserved. Some scientists believe that the information is somehow encoded in the Hawking radiation emitted by the black hole. Others propose the mind-boggling holographic principle, the idea that the entire three-dimensional world, including the inside of a black hole, could be represented as a two-dimensional surface, like a hologram. If this is true, it could completely rewrite our understanding of reality. The universe itself might be a hologram, a projection of information stored on a distant cosmic boundary. Black holes are more than just cosmic vacuum cleaners. They represent some of the biggest unanswered questions in physics, forcing us to confront the limitations of our theories and inspiring new ones that could change everything we know about the universe. If black holes and quantum mechanics seem mind-bending, string theory takes the concept of reality to an entirely new level. At its core, string theory suggests that everything in the universe, from the tiniest particles to the largest galaxies, may not be made up of point-like particles, but instead tiny vibrating strings of energy, and the way these strings vibrate determines the properties of the particles they form. But here's where it gets really strange. For string theory to work mathematically, there must be extra dimensions, more than the 3 dimensions of space and one of time that we experience. In fact, string theory suggests that the universe could have up to 10 or 11 dimensions. These extra dimensions are incredibly small, so tiny that we can't see or experience them in our everyday lives. But they could be all around us, tightly curled up at every point in space. While this might sound like science fiction, the mathematics behind string theory is so compelling that many physicists believe it could be the key to unifying all of physics. String theory also opens up the possibility of parallel universes or multiverses, other dimensions or realities that coexist with our own but are inaccessible to us. If true, it would mean that our reality is just one of many, each with different laws of physics and possibilities. If proven, string theory could fundamentally change our understanding of what reality is. Our universe, with its familiar laws of physics, might be one facet of a much larger, more complex multiverse. And those tiny, vibrating strings of energy, they could hold the key to understanding everything, from the smallest particle to the entire cosmos. While string theory is still being explored, its implications are profound. It forces us to rethink the nature of existence and raises mind-blowing questions. Could there be other dimensions just beyond our reach? And what role do these hidden dimensions play in shaping the reality we experience? Time is something we experience constantly. The past flows into the present and the present into the future. It seems so simple, but in the realm of physics, time is anything but straightforward. Einstein's theory of relativity showed us that time is not an absolute universal experience. In fact, time can stretch or contract depending on how fast you're moving or how close you are to a massive object. This is called time dilation, and it means that two people moving at different speeds could actually experience time differently. To an astronaut traveling at nearly the speed of light, years may pass in just seconds for someone back on Earth. But time gets even stranger when we start considering theories like the block universe theory. According to this view, time isn't something that flows. Instead, the past, present, and future all coexist simultaneously, like a giant 4-dimensional block. In this model, time doesn't really pass. Instead, we experience moments in a sequence, but all those moments exist at once. It challenges the very notion of free will and change. If the future is already out there, are our choices predetermined? Another approach, called presentism, argues that only the present is real. The past and future don't exist except as concepts in our minds. This view aligns more with our everyday experience but has trouble fitting into the framework of modern physics. So, what is time? Is it a flowing river, a fixed dimension, or just an illusion created by our minds? Understanding time may hold the key to understanding reality itself. Time governs everything we do, but we still don't fully understand what it is. Is it a fundamental part of the universe, or just the way we humans interpret change? One thing is clear. Our everyday experience of time may be just a small part of a much bigger picture, a picture that forces us to reconsider what's real and what's imagined. In physics, the observer effect suggests something extraordinary. Observing a system can change its outcome. This key principle of quantum mechanics raises an intriguing question. Could consciousness itself shape reality? Consider the famous double-slit experiment. Scientists fired particles like electrons through 2 slits, expecting them to form 2 lines. Instead, they saw an interference pattern. Particles behaved like waves, but when observed, they acted like bullets again. This suggests that observation affects particles' behavior, as if reality doesn't fully exist until it's observed. Does consciousness have the power to shape the physical world, or is it simply how we measure quantum systems? Some theorists speculate that consciousness might be deeply intertwined with the universe's very fabric. Could awareness be a key element in how reality unfolds? The nature of consciousness has puzzled humans for centuries. If the observer effect shows that consciousness plays a role in determining reality, it could open doors to understanding not just how the universe works, but why it exists at all. The connection between the observer and the observed challenges everything we thought we knew about reality and may reveal deeper truths about existence itself. Throughout this journey, we've explored some of the most mind bending theories in physics, ideas that challenge the very nature of reality as we know it. From quantum mechanics and black holes to string theory and time, these concepts push the boundaries of what we thought was possible. We've learned that the universe is far more complex than it appears. Tiny particles can exist in multiple states at once. Black holes may contain the key to understanding space and time, and extra dimensions could be lurking just beyond our perception. Even the flow of time and the role of consciousness challenge what we've taken for granted. But this is just the beginning. As science advances, we may unlock even deeper truths about the universe. New breakthroughs in quantum computing, cosmology, and artificial intelligence could give us the tools to explore the most profound questions humanity has ever faced. What is reality? Why does the universe exist? And where does consciousness fit into the grand scheme of things? The quest to understand the universe will continue to push us into uncharted territories, and with each discovery we get closer to unveiling the true nature of reality. The future of physics holds infinite possibilities, and it's a future where the very fabric of existence could be rewritten. As we look forward, one thing is certain: the more we discover, the more our sense of reality will evolve. So, stay curious, keep questioning, and remember, our understanding of the universe is still unfolding. As we come to the end of this journey through the mysteries of the universe, it's clear that the reality we experience may be just a fragment of a much larger, stranger existence. We've explored the bizarre world of quantum mechanics, where particles behave like waves until observed. We've ventured into the depths of black holes, where space and time seem to break down, and into the realm of string theory, where extra dimensions may hide just beyond our perception. We've also asked profound questions about the nature of time and its flow, and examined the relationship between consciousness and the observer effect. These mind-bending theories force us to rethink what we believe about the universe and even about reality itself. Is the universe an objective, fixed thing, or does consciousness play a role in shaping it? Does time flow as we experience it, or are past, present, and future all existing simultaneously? While these concepts challenge our understanding, they are just the beginning. The future of physics holds even greater mysteries. New developments in quantum computing, cosmology, and artificial intelligence could offer deeper insights into these questions. And perhaps one day we'll have the tools to understand reality on a level that's currently unimaginable. But the beauty of science is that it constantly evolves. With each discovery, we uncover more layers, and our understanding of the universe continues to expand. The quest to understand reality is never ending, and that's what makes it so exciting. As we look to the future, one thing remains certain: the more we explore, the more our understanding of reality will evolve. The universe is filled with endless possibilities, and we are only at the beginning of this incredible journey. So, stay curious, keep asking questions, and never stop exploring, because the answers we seek about reality might be just one discovery away.